Good morning, kids. This is the class based on solving differential equation by another process, that is homogeneous differential equation, and how to solve it. In previous class, I was doing variable separable that you might have understood. Now in this new class, I'm going to take up homogeneous differential equation. At first, we must know how we can understand that this is a homogeneous differential equation. First, you recognize the type of equation given to you. Once you are clear with it, only then you go for the selection that which process you are going to follow. Actually, the problem is that in your board exams, the questions are mixed up. So it is on your practice that you will select it, which process you are going to follow for solving each of them. Because there it is not written that it can be done by variable separable method, or it is done by first order method, or it is done by homogeneous method. So at first, the given equation is to be recognized first, that whether it is homogeneous or not. So how do we know that this is a homogeneous differential equation? My first emphasis will be on that only. If you have got an equation like this, I'm putting the heading here, homogeneous differential equation and their solution. Again using shortcut equation, this is homogeneous differential equation. See, the variable are two here, f1 xy. I'm indicating it by this, and here y and x both are getting mixed up. Let us take another example, f2 xy. Every time I'm using two variables, and in these two variables I am finding that variables are mixed up in such a way that it is difficult to separate these variables. Again, I'm taking the second example. These are examples I am taking from NCERT course book. These are the examples given here that you can even go through after finishing the lecture. You can check whether the equations are given here, they are homogeneous or not. But again, I'm emphasizing on these two things, that there are two variables here and both the variables are used. So if any equation is like this, or you can generally say, generally you can say f1 and express one in terms of the other, express y in terms of the other. That means you can say y equal to lambda x or x equal to lambda y. You can use lambda or any constant. So if I am using this, I'll say that I have written it in single variable. In place of y, I'm writing lambda x, and in that case this will be, y square equal to lambda square x square. So you can say lambda square x square plus 2x lambda y, 2x lambda y, and this becomes, you know, lambda common, lambda x plus 2. In place of y, I have put lambda x. Is it so? So in place of y, I have put lambda x. So 2x is there, and here it is lambda x, and this time you are getting x square common. It is x square common, lambda square plus 2 lambda, like this. So here I can generally say that a function is said to be homogeneous. This is the definition of homogeneous function. A function is said to be homogeneous function of, it can be of any degree n. A function is said to be a homogeneous function of degree n if f lambda x comma lambda y is equal to lambda 2 x and y for any non-zero constant lambda, for any lambda not equal to 0, for lambda is a constant. Now you find that the power of lambda becomes 2. So how will you know that it is of degree 1 or degree 2 or degree 3 equation? That is to be understood clearly. So let us check. You can generally say, and this can be in terms of x, y. Turning the page here. So if I take the first example first, fxy equal to x square, as I took common there, y square upon x square plus 2y upon x, and that is equal to x square, some another variable I'm taking, h1 into y upon x. Or similarly, f1 xy can be y square 1 plus 2x upon y, that is this time y square h2 and x upon y. So this can be both way written in this form, and similarly others can be written. So you can take some example here. You can take some example here and decide how will I know that this is a equation of degree of the form homogeneous, and taking an example here. So suppose someone writes dy by dx is equal to fxy is equal to gy upon x. And if I write y equal to some lambda के बदले अब हम यहाँ पर v dot x यूज कर सकते हैं. So your equation becomes dy by dx equal to v plus x dv by dx. Dy by dx equal to, here I have differentiated that function on differentiating with respect to x. With respect to x, I am getting first as it is, differential of second is 1, plus second as it is, differential of first with respect to x is dv by dx by product rule. So this is Lagrange differential, dy by dx equal to bx plus dv by dx. And now if you substitute this value in this equation, substitute dy by dx. So you are getting v plus x dv by dx is equal to some another variable here, v. So x dv by dx equal to gv minus v. So what I'm observing here, that this has been expressed in a new variable, and I can say that I'm going to the first exercise here, that is variable separable. You can write any function in terms of v minus b. The variable got separated, and here it is dx upon x. This step is variable separation. So what I did, the main thing is to be observed that I started by substituting something, bringing all in such a way that they can be expressed as variable separable again, and now I can follow the similar processes for solving. By integrating on both sides, I can go for the integration of this part, go for the integration of this part, and can solve it. So what is to be observed in these equations? What I'm going to observe, if the differential equation is of the form dy by dx is equal to fxy, where fxy is a homogeneous function of degree 0, is a homogeneous function of degree 0, then we make substitution, we make substitution x upon y equal to v. So x equal to v into y, and further proceed and further differentiating both sides with respect to y, differentiating both sides with respect to y, we get dx by dy is equal to v as it is into 1 and plus y as it is into dv by dx. And we can again proceed further like the previous page what I did. So in all those cases, I am finding that the equations are simpler, can be easily understood. So how will you check that this is a homogeneous function of degree, any degree? In each term, we have to observe that if the degree is the same or not. At the same time, the process of separation of variable goes like this, either in terms of x or in terms of y. It can be better understood if I take a very beautiful example of NCERT. It says x minus y dy by dx is equal to x plus 2y. What I'm observing, that the sum is in the form of two variables, in the form of two variables, and it is homogeneous because the degree of each term, degree of, for homogeneity what I check, degree of each term must be the same. So what do you observe? The degree of x is 1 here, degree of y is 1 here, On the right side also degree of x is 1 and degree of y is 1. So if I write in this way, the function becomes x plus 2y upon x minus y. And at first, it is very essential to check the degree of the variable. So you can write like this, check the degree. This is equal to, as I have substituted, lambda x and lambda y in another variable, lambda x comma lambda y, and then it becomes, for x I am putting lambda x, for y I am putting lambda y. So lambda x plus lambda y, twice of this, upon lambda x for x and lambda y for y. And if you take lambda common, you get x plus 2y. From here also lambda common, you get x minus y. So what I am observing, that lambda and lambda both gives lambda 0. So it can be lambda 0, and again this is x plus 2y by x minus y, that I have expressed as fxy. So you can simply replace it as fxy. And what do you observe here? That डिग्री 0 का ये एक homogeneous equation आया. So this is a homogeneous equation of degree 0. This is a homogeneous equation because sometimes in question you may be asked, check whether it is a homogeneous equation or not. So this is a homogeneous differential equation of degree 0. So it is homogeneous. So the given differential equation is a homogeneous differential equation. Hence I have decided that this is checking for homogeneity. This is the most important part. First you decide whether it is a differential equation and is homogeneous. And after that I am telling you how to solve it. So what I told you, express y in terms of a new variable vx. So my equation becomes dy by dx is equal to x plus 2y upon x minus y. We have finalized that this is a homogeneous equation. Now, what I have told you, you express y in terms of a new variable vx and differentiate it with respect to x after checking the homogeneity. So differentiating with respect to x gives dy by dx is equal to, again I'm using Leibniz rule, v into x का x के respect में 1 plus x as it is, v का x respect में dv by dx. So you are getting dy by dx is equal to v plus x dv by dx. And what do I do? Substitute this in this equation, in the given equation. Substitute dy by dx in first. So if I substitute this value, it is entirely in a new variable. See, v plus x dv by dx is equal to, I'm putting x, then 2 into vx for y, and here x minus vx. And then proceeding further, take x common, 1 plus twice of v, take here x common, 1 minus v, x gets cancelled, so x dv by dx, and this is the step where I'm going to write it in terms of a new variable, 1 plus 2v upon 1 minus v, and this v is transferred to this side, this becomes 1. By taking LCM, this says 1 minus v is the LCM. So this is 1 plus 2v minus v times 1 minus v. So 1 plus 2v minus v plus v square upon 1 minus v. So you're getting v square plus v plus 1 upon 1 minus v. This is x dv by dx. Is it so? This is x dv by dx. So I can write in another way. This is x plus dv by dx. No, x into dv by dx. X into dv by dx. Further, x into dv by dx is equal to this. Therefore, if I separate the variable using variable separation, I'm getting v minus 1 upon v square plus v plus 1, taking this negative sign common from the denominator, minus dx by x. So in this way I have separated variable now. Now I'll see, once I separate the variable, I will integrate on both sides. So if you integrate it, v minus 1 upon v square plus v plus 1 dv equal to negative dx by x. And now I'm entirely on that process where I can express this in terms of this. So it's better if I write b square plus b minus 1. You can say, here the totally integration parts comes. So you can write, this is a quadratic, this is a linear. If I let this to be b square plus b plus 1 as t, a new variable again. So dt becomes 2v plus 1. This becomes 2b plus 1. So it's better to write 2b plus 1, or if I subtract 3, I'm getting this, and but this 2 is becoming extra here, so I can write half here. This is the technique of integration again. So 2b plus 1 minus 3, that is 2b minus 2, and the differential of lower one is matching at the top. So this is better to think like this rather than going by any square completing formula. But that can be done by square completing also. But I'm not following that because simple use of technique will help you. So this upon v square plus v plus 1 minus half of 3 times integration 1 upon v square plus v plus 1 equal to negative log x plus c or c1, new constant c1. Here I'm getting half integration dt for this one because 2b plus 1 dv is dt. 2b plus 1 dv is dt from here. So dt upon t, this will again give me log t, half log t, minus 3 upon 2, or here I should go by, I'm left with no choice here, I have to complete the square. So it is again a square completing, you have learnt in integration part, b square plus 2 into v into half plus 1 by 4 minus 1 by 4 plus 1 here. plus 1 here. So I'm getting space crunch here. So this gives half log of t minus 3 by 2 integration, and here it is dv upon b plus half whole square minus 1 by 2 minus 1 by 4. So that is going to be 1 by 2 plus 1 by 4 is 3 by 4. That is root 3 by 2 whole square. And this is taking the formula x square minus a square. So this gives 1 by 2 log of t. I have supposed v square plus v plus 1 plus 3 by 2. And there is a formula of tan inverse here. That is 1 by a, 1 by root 3 by 2, 1 by a, tan inverse v plus half by root 3 by 2 is equal to negative log x plus c1. The first sum is becoming so lengthy that you might be annoyed, but this is the way mathematics goes on, because once the child gets irritated, he cannot do mathematics at all. So for mathematics, we need a lot of patience, plus for doing mathematics, we need a lot of patience, 3 by 2 and 2 by root 3. So that gives 1 by root 3, I think, or root 3 only. That gives root 3 tan inverse v plus half upon root 3 by 2. If I take LCM, this becomes 2b plus 1, 2b plus 1 upon root 3 and plus c1 is equal to negative log x plus c1. So it is half log v square plus v plus 1 plus half log, or if you bring it to this side, this is half log x square. Half I am putting here extra so that I can take the LCM again and use the logarithmic law, and this gives root 3 tan inverse x or 2b plus 1 upon root 3. So the answer becomes like this: half log v square plus v plus 1, and if I bring this minus log x as plus half log x squared like this, I'm using a logarithmic law here, is equal to root 3 times tan inverse 2v plus 1 upon root 3 plus c1 plus c1. Or now you will go for all the replacement all the way. For v you will put y upon x. So if you go for now, put v as y by x, so you will get half log y square by x square plus y upon x plus 1 plus half log x square is equal to root 3 tan inverse 2y upon x, that on taking LCM will give you 2y plus x upon x root 3. So that is root 3x, and plus I can write 2c1 here. Why I'm writing 2c1, that you might have understood, because I bring it to this side. So on taking LCM, the final answer can be written like this: log y square plus xy plus x square, and this is half here, that is crossed over to that side, as I told you in previous step, is equal to twice of root. If you remove this half here, twice of root 3 tan inverse 2y plus x upon root 3x plus 2c1 is c only. So this gives the final answer. The question needs a lot of patience, and in first sum only, the sum is so lengthy that you might get frustrated sometimes. But I'm not saying that every sum is going to take so much time. Since the exercises are going ahead, so difficulty level will also increase. So your diligence, your intelligence of mind, your substitution, and you know, the gut to solve the sum. I will not give away unless I get the answer. This would be a tactics of every mathematician, that I'm not going to give away unless I finish the sum. Only this will help you, and this will help you to solve the problem. So this is the way we do the sum differential equation, first sum. See you in the next session. Thank you.